So, the continuation to one of the topics in beam stresses or stresses in beams is the horizontal shearing stress, and it's represented by the same formula or same symbol that it's tau. So, horizontal shearing stress is developed due to shear forces, and you know what shear force is all about. It's the kind of force that breaks your beam or breaks your structure. So let's just focus on beams since this is a stresses in beams. And if the same gihapon atong buhaton, horizontal, if we're gonna consider a simple beam, acted like this one, or you can just actually imagine a deck of card and it's being supported by your two hands holding the deck of card at both ends of the deck of card, and then there is an applied force at the middle of the deck of cards, and then what happens here to every card, it splits from one another as you observe. So that's what we are trying to define here. After the application of P force, this one, the tendency of the particle or each bond or bonding of the particles of the material, okay, loses its contact. So if you try to imagine this con application, so as you have seen here, we have forces applied tangentially along the longitudinal section of the beam. So this is the force that breaks the fiber or that splits the fiber from bonding, and then that's the reason why nana siya cracking. So basically, not only the horizontal cracking and the vertical cracking, so we have to consider all the shearing stress experienced by the structure. So that's how we are going to respond. So for example, since nagisgot man tag horizontal shearing stress, then we will be getting the forces that cause the shearing of the body, and that shear force is the reason why there are splitting of the members or of the fibers. And if we try to consider the stress diagram of a rectangular section, as you observe here, at the neutral axis, this experiences the greatest amount of stress. So we have to always remember that the maximum shearing stress occurs at the neutral axis. So it's different from the flexure, that ang naa sa whenever ang flexure, ang maximum flexure is on the outermost fiber, wherein ang iyahang pinaka or iyang zero stress is at the neutral axis. Here in horizontal shearing stress, for a homogeneous section like one material lang siya, the maximum horizontal shearing stress is found at the neutral axis, and then it's different whenever we have a composite section, meaning the material is made up of, I mean, the whole section is made up of different materials like steel combined with timber or of wood. So it's like that, it's different. So asa man ang maximum shearing stress whenever natin composite section, then it's at the joint kung asa gi-connect ang duha ka material. So dito dito na to ma-measure ang maximum stress, maximum horizontal shear stress tungod sa iyang material nga dili siya homogeneous or non-monolithic. So there, whenever magisgot og horizontal shearing stress, we will be considering that tau is equal to VQ over IB. So the formula is tau equal to VQ over IB, where the V or the tau is the horizontal shearing stress, and that should be in Pascal or in PSI. And then the V is the shear V, the shear force that we can get in the shear diagram. And then the Q is the statical moment of an area, meaning it's the rotation of an area about the neutral axis. So it's basically what we're gonna do here is to get the product of the area and the centroidal moment arm of the centroid of the area padong sa neutral axis. So I'm gonna show you later on how to get the statical moment of an area. Then I, of course, this is moment of inertia, and then the B is the base where asa ni agi ang ato ang shear. Okay, so kung unsa atong i-consider nga fiber, then mao na atong i-consider nga base. So asa siya nga portion. So, by the way, let me just stress this out. Whenever mag-get ta og shear, maximum shearing stress, then we have to make sure that we are looking at the value of the maximum shear force, shear diagram, meaning unsay pinakadako nga value nga ato makit-an sa shear diagram regardless of its sign. So, bisan pa og negative or positive siya. So, remember, I have presented already that the negative shear and the positive shear are of different sense, but they are of same effect. So, bisan pag upward force or downward force, ang effect niya sa beam or material, it's still breaking. So, that's why it's either positive or negative. So, regardless of the sign, just choose the maximum value among the shear forces in the shear diagram. Okay. And then, by the way, we can actually have the maximum horizontal shearing stress for a rectangular section. This is only for rectangular section. This is not applicable to composite section. So, whenever natay rectangular section, then we can use 3V over 2A, where it's just a fraction, 1.5 of the shear over the area of the section, and shear that we are using as the maximum. So let's try to have example number 1.